Hi kids, Smath here. Going to walk you through a Charles's Law lab, a lab where we're going to estimate the temperature of absolute zero. So here's what I've got going on for you. Pardon me while I move the camera a little bit. Right over here in this beaker, I've got an Erlenmeyer flask that's heating up. Now, this has a hole in it, hole stopper, 3-hole stopper, and a little glass tubing going through it. And we're getting this water up so that the water's going to be 100 degrees Celsius. So this is going to be our hot condition. And what we're going to do is we're going to take this flask out, put it into the sink with water in it, and that's going to fill up with some cool water, and that's going to be our cold conditions. See, if we have hot conditions and cold conditions, that's going to give us 2 data points, and those data points are going to let us estimate absolute zero. Should work pretty well. We should get pretty good data here. So I'm looking right now, and our thermometer's reading out really nicely at 99.9, and you know what? We're just going to make that 100 degrees Celsius, okay? So we're going to take this out, get that out of the way, and then this next step has to happen pretty quick. But what's going to happen is I'm going to put it underwater so that when this gas contracts, it's going to pull some of that cold water into it, and we're going to be able to find out the volume of the cold. Right now, the volume of the hot gas is occupying the whole flask. So here we go. We're going to take this, we're going to put it underneath the sink, and it's going to fill up with water. Now, you guys aren't going to be able to see this very well, but it's kind of cool. I wish y'all could do this in class. Here we go. Out and in, and we open it up, and some water rushes in, and we're just going to leave this under the sink for a little while right now. It's not hot anymore. It's already cooled off. And what's happened is some water has rushed in and filled up this flask. And so we're going to let it get down nice to cool temperature. Okay? Cooling down, cooling down. And now look, we've got water inside of that flask. So now our cold volume of the gas was about this big. All right? We need to measure that. So here's how we do that. We're going to take this out. We're going to grab our graduated cylinder. We're just going to go, okay, boom. We measure that and we go, hey, that's perfect. That's 45 mils. Okay? Now what we need to know is how much does the whole thing measure? I'll pour that out. Now get this thing good and filled up. Just like it would have been when it was sitting in that boiling water right there. So I'm putting my little flask in this. Ooh, look at there. There we go. Then we're going to take this out. Now we're going to measure how much water's in this thing. We're going to fill it up. Fill that on up. Yep, okay. We're going to fill that up again, and it's going to go okay. And we get the total mass of the total volume of this thing, and it measures out to be 201. So here's what I've got for you. I'm going to bring you on over here to the board and give you some of the details of this. So right now, this is what happened. We had a flask that was in hot water, 100 degrees, heated it up, put it in the sink, some of it filled up with water at 17 degrees Celsius. I measured that before we came online. Then we measured how much water went into it. That was 45 mils. Then we measured the whole thing. That was 201. So what we know is that this volume was 156 when the temperature was 17. When the temperature was 100, it was 201. What good does that do us? How does that help us with absolute zero? Well, here you go. If we take and make a graph of temperature in Celsius versus volume, that's going to give us a nice straight line. And what we're going to do is put a regression line on that. Now, you guys should know how to graph by now, and if not, ask a friend, look it up online. But what we want to do is we want that graph of temperature versus volume on your calculator with a regression line, a simple regression line, and you're going to send me a screen capture or a picture of that calculator with that regression line. And the thing that should be cool, the part of it that gives us absolute zero is if this is y equals mx plus b, the y-intercept, whoop, down here should be absolute zero, negative 273 Celsius. That's our Charles's Law Absolute Zero Lab. I'm Smath. I hope this video helps you.